Hello, my name is Gerard Fithian. I'm here today to introduce you to our new range of ADTS test sets, our GE pitot static testers. Exciting new range using the latest technology, built on the backbone of our Druck technology, where we've supplied hundreds and hundreds of ADTS test sets into Defence Force and commercial aviation around the world. This is our new family. So without further ado, I'll take you through the main features of this, and we are calling it ADTS Unplugged. So the reason for that is basically around our user interface. So we've now got a self-designed capacitive touchscreen user interface, which has got swipe screen technology, very intuitive, symbols on there as well. So we're trying to make this as easy as possible to learn and as easy as possible to use, because I know that you don't pick these things up necessarily every day. So when you go back to it, you don't necessarily want to be remembering, oh, I need to press number 2 to make the remote hand terminal work, for example. Okay, so it's a capacitive touchscreen, it's light in weight, very portable. So now we can sit in the cockpit with not being hindered with hoses or wires or cables, and simply drive and set our altitudes, airspeeds, and do our testing hands-free. And the next slide shows you a picture of our ADTS Touch in the cockpit of an A380. This is one of our customers who has acquired several of our units and is very, very happy and very pleased with the user interface, and yeah, have a lot of good things to say about it. And as you can see, we're wireless. It's a Bluetooth technology, wireless, and we're in the cockpit of an A380. It's not your standard Bluetooth. You will not be able to pick this up from an iPhone and connect to it, for example. So it's a much more powerful Bluetooth technology. Okay, so here it is in the cockpit there, and running through a test for our customer, and very intuitive screen on the bottom left hand side. We're in control mode, it's telling us, and we're driving the aircraft to set different altitudes and airspeeds just with the touch of a screen. Okay, so there's a family here, right? Our entry level is the 550F. The 542 is our smallest unit, very reasonably priced. We've made sure that we meet the market with this product line, and we've done that with commonality through the range. However, one thing that will always remain the same is the ADTS Touch, so that user interface, whether you're picking up a 552, a 553 or a 554 and pairing your touch, you will know immediately once you've learned one unit, you'd be able to operate any of them if you were to, for example, to have a fleet. So the 542, it will control into 3 litres of volume quite happily. Modern aircraft today, some have very small internal volumes, and like old 747s. So it will get there and maintain the rates. Obviously, if we're outside its volume capability, then it will get there, but may not be able to achieve the rate of climb. But that's one of the payoffs. But another advantages as well for helicopters, for example, we've got a low speed, better calibration for low airspeed testing. And if we move across now to the 552, so this platform size and footprint is the same now for the other units as well. It's it's a 2-channel unit. Comes as standard with a 15-month interval between calibrations and an optional 18-month, and we've been able to achieve that with the use of our new sensor technology, which we've been developing for many years. Another version of our resonant technology called TERPS, which is Trenched Etch Resonant Pressure Sensor. I'll mention a little bit more about that in a moment. Okay, so the 552 has 5,000 hours of pump operation before it requires maintenance, which is a hell of a long time, and larger volumes it can control into, so no problems there or considerations to take into or anything to take into consideration. If you think about extending your calibration to 18 months, then that's a huge savings in cost over the life of the instrument. Incidentally, the 542 has an option to extend to 15 months, and the 552 starts at 15 months as standard. Then we have the 3-channel. So 3-channel gives us another PS port for aircraft that have got or need angle of attack measurements on smart probes, for example, like on an Embraer aircraft, where you need to calibrate the angle of attack sensor and test that. So the 3-channel can do angle of attack. And then we have the 4-channel, which is basically you've got 2 PS, 2 PT, and they're completely 2 independent control units inside that unit, and therefore that enables you to do things a lot faster. You do 2 things at the same time, and there's some other benefits of that. And it can operate as a 3-channel as well for angle of attack. Now the next good news story is, after we go through the front panel of the 542, which is similar for all intents and purposes to the other aircraft, obviously PS, PT, those adapters can be changed. I'll mention that again in a moment. And we have indicators on the front panel that will show you the power's on, is the battery backup option coming soon, is that in charged, have we got antenna, has it got connection with our ADTS touch, and then is the aircraft safely at ground. So somebody outside of the aircraft hasn't got the touch can see whether the aircraft, for example, is communicating or whether it's safely at ground, before they went around trying to pull any adapters off the aircraft. So I'll move quickly through. So the 552, as you see, the panel size is the same on 552, 553 and 554. So if you buy the 2-channel 552 and later want to put another channel, we can do that for you, so you can move on to a 553 later. And similarly, you could take it to a 4-channel unit in the future. So we have this upgradability of the product, which is great. So you're future proofing. If you are your company might be acquiring, or as a service MRO, you may be needing to do angle of attack measurement. So if you didn't get it in words, basically the 2 channels can be upgraded to a 4. So in the 4-channel 554, we have all 4 channels in there. So 2 552s effectively in one box. Okay, so quickly there we have 2-channel testing. So one side, if we're not using a manifold, one side then the other. And then we have our 3-channel. So 3-channel doing the angle of attack, but 3-channel can also work as a 2-channel. And finally the 4-channel, which has 2 independent controllers, so we can actually do the tolerance test between captain and first officer very easily and make sure the alarm goes off if there's a discrepancy outside of tolerance between the captain and first officer's instruments. Okay, we're one of the only companies that are putting their own sensors in here. We've developed this over the last 15 years, basically, our trenched etched resonant pressure sensor. We're achieving a fantastic long-term stability. It's at least 10 times more accurate than piezo-resistive technology, and that's how we can extend those calibration periods. So fantastic technology. And we've made it a lot easier now for in terms of adapters. If you like, I like this adapter, I've put it on there. This makes it a mini manifold, if you like. So we have put that onto any port, and now you have 2 channels on that port. So, and there's a switch on the side of the unit, so you can isolate either one or the other or operate both at the same time. And there are many more adapters that are very easy to fit, options that we've not provided in the past. So you have your quick coupling type connections, etc., AN4, AN6 and so on. So there's an introduction and an overview of how all the models fit together. So key points: ADTS touch, easy to use, extended calibration period, cost of ownership, highly accurate sensor, meets RVSM requirements easily. So we're talking, it's much better than I think we need at 41,000 feet. We've got to have an accuracy of 22 feet. We're way inside that. At sea level, we're plus or minus 3 feet. So amazing instrument, amazing platform. Thank you for listening, and hopefully you'll follow on and look at our training video at a later date or straight after this one. Thank you very much for listening. Goodbye. Hi, I'm Jed Fithian. I'm here today. I'm going to take you through an instructional video showing you all the features and how to operate our new ADTS 500 series of pedostatic testers from GE. I'll introduce you to our ADTS Touch wireless hand terminal, which has commonality through throughout the whole range of the ADTS 500 series. So once you know how to use this, you'll be able to operate the whole range or whole suite of products that we have. Today I'll be working on our ADTS 542. Thank you. Okay, so I've taken the lid off, we've powered the unit up. The ADTS Touch is now showing you the dashboard screen, and we'll cover that in more depth later. So just a quick walk around of what we've got on the 542, which is the 2-channel unit. We've got the PT out and the PS out outputs there. Color coding is entirely up to you. We provide you with some labels to recolor. These are AN4, but you can have numerous different adapters as well to be fitted, and it's just simply 2 screws out and the new adapter goes in. AN6, quick coupling connectors, etc. So we've tried to be a lot more flexible than we have been in the past on our connections. Here's just some indications. So power's on. Battery indicator here is for a development that's coming very soon, where we will have a battery backup option. It will be an option, and it will be a battery that will be able to operate and do a test with the unit, not just a safety backup. This antenna is indicating our Bluetooth, because we can connect this device with the cable to the ADTS Touch, but get the most out of it, we need to go to our industrial Bluetooth connection. Therefore you've got no cables in the cockpit. And this little aeroplane symbol here is explaining that the aircraft is safely at ground, as it will do as you go through a test and control back to ground. So that's just giving you indications. This connection here is for our cable. So we supply 2 cables, one's 18 meters, one's 5 meters, and there's options for longer cables if you require. However, if you're using Bluetooth, that's not really an issue. This unit is connected to the base. Underneath there is a connection here, and it just literally slots on to that connection. And it at this time is charging the battery, the internal battery of this device, and I'll cover that in more details about all the different charging options that you have via the cable, etc. Even if we go to standby mode, it will continue to charge while it's docked on the station, so it doesn't have to be on to be charging the unit. So the instrument in the cockpit, obviously it's an old analog gauge, amazing what you can get off eBay. So the operation here would be to set what we call the Colesman window. This particular unit is off a DC 10, and you can actually enter in millibars or in inches of mercury. So it's 1013.25. We're not that much accuracy there, but it's 29.92 is mean sea level. So this needs to be referencing the same as our instrument's referencing, and as you can see, we've got a negative altitude, and it's around about spot on, to be honest, in comparison to the ADTS, so still a good gauge. Okay, before we get started, every time the unit powers up, it will come up in what we call limits helicopter. So we have limit protection there, so as an operator engineer, you do not want to enter a value that would damage any instruments on a particular aircraft. So therefore, by using the limits function, that enables you to be safe in operation and be confident that you won't damage anything. So the reason we start in helicopter is because that's the lowest parameters that you can set, particularly for the ADTS. So you're not going to if you connect to a fixed wing, you're in helicopter, you're not going to do any damage. Connect to a helicopter, you're not going to do any damage by trying to take a helicopter's altimeter to 55,000 feet, for example. So it may be something that you've got to remember, but certainly something you will soon come to know, is that the first thing you need to do is make sure you've got the correct limits selected for the aircraft type that you're working on. So if we go back to the home screen and we go to settings, and I go scroll down here to look at ADTS settings, I just go into ADTS limits. Now I want to select limits. So at the moment, as I said, it was on helicopter. We've got a typical fixed wings, or we've got max. So max aero is the maximum capability of the instrument. For the sake of the test, that's the one I'll select. But let's just go back again just to show you, and we'll go through this in another video or later in this video. You can put custom limits in there. For this case, I've put a 787 in there, and it's very easy for us to set that up. So being in helicopter makes you go in and make sure you've got the right settings for the type of aircraft you're working on. Okay, so here we are, max aero limits I've selected for this demonstration, and at the moment we're in measure mode, so simply like the gauges you saw earlier, we're just measuring what the pressures of the day and what that relates to in terms of, in this case, feet and knots. So the two modes we've got are measure and control. So we need to be in control mode in order for us to be able to apply the required pressures to simulate altitude and airspeed. Now let's get familiar with some of the icons across the bottom. There's a back button, there's a home key, there's a help key, and in fact the whole operating manual stored on the unit as well if you ever need to, or you can always, there's a USB connection as well, which we'll talk about later, and you can save it to a USB, but don't worry, we do actually supply one with the unit as well as you know, having to be able to print one out. Okay, the next one, you'll see an aircraft coming to ground. So when we're at an altitude and we finish the test and an airspeed, and we just want to get everything back down to ground, disconnect all those adapters from the aircraft, we just hit the ground button and basically that will fly the aircraft safely back to ground. So it's a nice little feature. Next one here is where we toggle between, this is a measure tape, so we're in measure mode, and control, where we see a gauge or an altimeter, for example, in control. So that's literally, we toggle from measure to control. The next one is units. So at this moment in time, this shows an aircraft, and that means that we're operating or displaying in aeronautical units, and I've selected feet and knots. You could select meters, you could select kilometers per hour, etc., but for this at the moment I've set feet and knots. Now I might want to know what the actual pressure value is at minus 54 feet, so I can toggle over, and there my PS now is showing me what pressure of the day is, basically 1015.22 millibar. So we're going to have a nice day. The sun will be shining. Okay, so one simple press again, we haven't had to go through a menu, and we're back in aeronautical units. Finally is on here we'll see an aircraft flying and a symbol of an aircraft breaking the sound barrier, and that's because if we press this button we now are displaying our speed in form of Mach. Okay, and when we're setting altitudes and airspeeds, if we are displaying in Mach and we, you know, take the aircraft to a higher altitude, the speed of sound will change at that altitude, but what the unit will do is keep a constant Mach value for whatever altitude you actually set with the device. Similarly, when we've got knots, airspeed in knots, it will control the pressures to keep that nice and constant as we change altitude, but may want to keep the speed constant. So that's constant airspeed and constant Mach. Okay, so let's start controlling. So what I'll do is show you now how we enter values and how we can adjust those, and talk about what these things over here mean. So first of all, we want to set an altitude, and you'll have a predetermined test maybe that you need to do, so you'll know that, but for the sake of this video I'm going to simply select 2, and I can use the thousands key there, 2,000 feet. Don't want you to wait too long, so I'm going to go to the maximum, which is 6,000 feet per minute, and I'm going to put in an airspeed of, let's say 180 knots at 300 knots per minute. I'm happy with that. Now nothing will start moving until I press the tick. So it's a great way to hold everything steady, you know. Alternatively, yeah, you could put an airspeed in and then hit go, and that would be trying to get to the airspeed, and then you can put your altitude in. But let's do it this way, so everything's ready to go, and off we go. So now the pumps in the ADTS 500 series will now control to those pressures. And if you could see the altimeter, we're going to take us up to 3,000 feet now and 180 knots. The ADTS will try to reach those 2 points at the same time. That's why the airspeed is going pretty slow at the moment. So the objective is that the two arrive together. When we actually achieve those values, you see we're pretty close on the gauges as well, so that's good. Good eBay gauges, thank you. These will turn green, so that we know we've actually achieved our set point. It's a nice little indicator that, yeah, okay, we're there. Okay, let's explain this. So this is like a loading bar, so familiar if you're loading some software, or but basically it's telling us to get in and achieving our 100%. Now this is a great feature on the right hand side of the screen. This is what we call, or I call, the effort meter. So this is telling us how hard those pumps are having to work in order to maintain the values that we've set. Ideally those two arrows should be right in the center there with this little point. So what this is telling me straight away, before I even go in to do a leak test, is I've got a leak, but the controllers are quite powerful, so they're able to control that leak and still maintain those set points. So for argument's sake, let's just see how bad that leak is. In order to do that, we would go over and do a leak test. I'll set the leak test up first. So in the leak test we have a wait time and we have a test time. So the wait is if we've, when we're changing pressures, you know that changes of temperatures is going to be causing variations in pressure as that temperature stabilizes. So we have a wait time to overcome what we call the adiabatic effect. And then obviously test time is how long you require to test for that leak. So you can come out and say, look, it's better than 100 feet and 1,000 feet. I think that's a light aircraft spec. So things are fine. Okay, so what I'll do now is I'll go back into measure mode for the leak test, and it will start leaking, I think, pretty fast, and you can see straight away. So I'll swipe over and I'll start my leak test. That's a pretty bad leak. I can see that it's within the parameters that are okay, so it's not greater than 6,000 feet per minute, which is the limit for my device that I'm testing. So all that's proving that, that those indicators, before I even went into it, those indicators were telling us that, hey guys, we've got a leak here. Let's try and fix that before we switch the controller off, or let's take it to ground and fix it straight away before we turn the controller off. However, there is one more safety mechanism that we've got called auto leak recovery. So if you've got a leak that is at a rate of descent faster, or rate of change faster for your airspeed than the limits of the aircraft, it will put the pumps back on and control that leak. Next question everybody asks is, how big a leak can it control? The simple answer is, well, if it did manage to get to the set points that you require, obviously with the leak it can control that leak. Therefore auto leak recovery kicks in very fast, and I'll try and demonstrate that a little bit later on. Okay, so there's my leak test, and I think I've got a serious problem, and I'm going to try and fix my leak now. Okay, so we just did a leak test. As I mentioned before, my system's got quite a big leak. When it displays the leak values, by the way, it always puts a T once the timer's finished, so that you know that that's the timed value in whatever units you've selected, in this case feet per minute. There's one other feature I'd like to talk about. Now, I mentioned before that this is an effort meter that tells me straight away before I even go into measure mode that this controller or the pumps are working very hard to maintain this altitude I've got set here. That means I know I've got a leak already. And there's a feature in the settings, in the ADTS settings, which is called auto leak recovery. And what that means is if we turn from control mode to measure mode and the leak that it detects is outside of the limits that we've selected in terms of rate of climb and in terms of rate of airspeed change, so we've got a big leak, the ADTS will automatically turn the controller back on to take control to save you from damaging any instrumentation that, you know, okay, if it's a standard sensor and it's not an analog unit, it may not be an issue, but in a lot of cases there'll be analog instruments involved, so auto leak recovery is there as your safeguard. So I'm just going to demonstrate that now. I'm back to pitot static, so we're in control mode. Now I'm going to switch it to measure mode, and if I'm correct and this leak is bad enough, it will turn the controllers back on and just hold it wherever it leaked down to. So I'm going to go into measure mode now. So in measure mode, and straight away it's leaked down, but the auto leak recovery activated, so we know we're okay and the pumps are back on. So we dropped a few hundred feet, but now we've taken control of that again. Obviously for a much higher altitude that's negligible anyway. So the normal procedure here would be to control the aircraft back to ground, hit the tick button, and this is the ground control feature. By the way, you can actually go in and change the rate at any time, so, but I'm happy with 3,000 feet per minute, which is the maximum for the helicopter I've got selected. So yeah, anytime, and same with any of the parameters, you can always go in and change that parameter while it's live in control mode. So now checking the ground pressures in case any pressure of the day has changed. It's equalising PT and PS, and now the aircraft is displaying that it's safely at ground. Okay, we're in measure mode, and now we can fix that leak that we had and reconnect to the aircraft. Okay, so let's just look at some of the other settings that we've got here. So we've been in pitot static using that. You've already seen some of the settings. For example, we've got the screen brightness, which is quite obvious. We can invert it as well, the screen. You may prefer it in a highlight environment or back to the dark for the sake of this video. We've got our ADTS settings, and the ones I'll focus on is auto leak recovery. I've got that on and I demonstrated that earlier. We've got pressure units, so currently in millibar, but obviously we can select a number of many different pressure units, but I'm happy with millibar, so we'll stay with that. Okay. So same with area units, it's the same, basically sit on there, in feet and knots, kilometers per hour, feet, miles per hour, meters and knots, so feet and knots, I'll stick with that. Now altitude correction, what's this? So it's password protected, so it means you've got to enter a pin, and it comes with default pins that somebody can change and customize, but basically altitude correction is the difference in height between the ADTS itself, not the touch, the actual ADTS, which for all intents and purposes will be sitting on the tarmac outside or in the hangar outside the aircraft, and it's a difference in height between the top of our unit and the reference level of the instrumentation in the aircraft. For example, so we're talking an error here at ground of plus or minus 7 feet, and we also talk about something called RVSM compliancy. That is, RVSM means that reduced vertical separation minima, so aircraft transitioned over a period of years around the world to fly with a minimum separation of 1,000 feet. It used to be 2,000, and from that it was realised that the instrumentation that was in the cockpit needed to be tested with a more accurate devices to ensure that they maintained within that RVSM compliant envelope. And once aircraft are flying at altitude, everybody will be referencing 1013 to keep that separation. So I think it's 22 feet at 40,000 feet error, is outside of the limits of where it should be. So for example, if we were looking at something like a Boeing 747, the height of the cockpit where the instruments are relative to the ADTS is quite a difference. So if you don't put a correction factor in there, then you're adding the height of the aircraft's instruments relative to the air data test set into your overall error. And that's simply entered in feet, or whatever units you're working in. If you're in meters, it'd be in meters. So you simply go in, enter the password and enter the height. And that will be different obviously for every type or model of aircraft, but certainly in an RVSM compliant area is something that you really need to be aware of. So we're okay with that. We're not going to go in and change anything. I'm in calibrated airspeed mode at the moment. The other one I've got is true airspeed. Select true airspeed. It will ask me to enter a temperature value. So true airspeed temperature is 20 degrees C, tick. I'm now in true airspeed mode. I want to go back to calibrated airspeed or indicated airspeed. So this is pressure speed that we're talking about. Don't get confused with ground speed. The pressure speed is, pressure is very important. It's very important parameter to measure in terms of how fast the aircraft is moving through a column of air, because it tells the pilot and also tells the autopilot if there's enough air flowing over the wings to give the aircraft lift. So as we get into thinner air at high altitudes, like over 30,000 feet or over 20,000 feet, then the air pressure speed is a direct indication of the amount of air flowing over the wings to keep lift. So that's why you can't just use a GPS, because a GPS can't make the calculation with respect to altitude and the thinning of the air. So very, very important pressure measurement. But we are at this moment working in calibrated airspeed and indicated airspeed, which is what these instruments are in. Okay, so just thought I'd add that little story for you. Basically, ground speed's all about arrival time. So it's like you're in your aircraft when you're flying and you're checking out how fast or how long it's going to be till you get there. That's all about ground speed, not your pressure speed, if you like. We can change the supervisor pin. I'm not going to do that. I'll keep the standard one in there. I did mention ADTS limits earlier. I can create new limits, for example. I have to enter a pin to do that, so not everybody can just get in there and do it. So I can edit some of the limits I've already got in here to make it easier for me. So if I take fixed wing, give it a new number, let's call it, let's do an A380, tick. Okay, and now what I can do is go in and edit the parameters for that particular aircraft that you will know from your manual. So let's say in this case I can do minus 2,000 feet is the minimum altitude that it can indicate, and I can go through and so on and edit these values as I move through. Okay, so we've got tick, happy with that, and now we can go through and say minimum calibrated airspeed is 0, but I could enter a negative value. That won't do because they don't go backwards. Tick, happy with that one. I can scroll through, and then I could actually adjust the pressure parameters as well as the knots or aeronautical units. So I'm not going to go through any more of that, but it just shows you very simply that you can go in, take what's already been set up, look at the manual, and basically enter those limits to ensure that when you're operating and you've selected the correct limits, that you will not go outside the operating envelope of the instruments in that particular aircraft. So, okay. So now we have 787 there, I did earlier, and we've just created an A380 that we can always select. Okay, so we did that by creating, now if I go to edit limits, 0268, tick, it will come up with the ones that I've already entered before. So I could go back and edit those values. Okay, so we'll just come out of that. I don't want to do that. Or I can delete the limits, so we'll come out of that. So that limits, again, is there for your protection and the aircraft's instruments protection as well. So you'll have to do that. Okay, so we'll come out of the ADTS settings now. Regional settings is for languages that you may want to select, and also dates, times, etc. Screen rotation, we can actually rotate the screen and turn it the other way. There is an accessory where the unit can be mounted into the accessory that hangs around your neck and sits on, sits about mid-chest height, so you can operate it hands-free basically. So that's where you'd want to rotate the screen in that particular instance. Bluetooth is on auto connect, and obviously when I take it away from the instrument, the two will talk. Now, it's not a type of Bluetooth that will be detected by your mobile phone or any other Bluetooth device, so don't be concerned that somebody could identify it. It is a different standard of Bluetooth. It's a more powerful Bluetooth with an extended range, so it's not something that's searchable. If somebody did have another ADTS touch and you were connected, the second one that would, if it could connect, the second one would become a slave and would not be able to take control of the ADTS set. And in some cases, some customers like that idea because they want to, somebody else on the ground there just checking out and keeping a track of what you're doing. Okay, so we've looked at most of the settings there, and now let's have a look at tools. Calibration, that's obviously if we want to calibrate this instrument, and we do provide instructions for that. However, we do have many support centres around the world that can do the calibration for you. However, I know some major airlines and smaller as well will have their own calibration lab, so the calibration menu is there to calibrate the instrument. And I'll point out that because of our sensor technology, and we design our own sensors for this, and we're probably the only company that do actually use our own sensors, and the 500 series is our latest resonance sensor, which is our trenched etched resonance sensor, which has been in a long time development, has enabled us to achieve amazing accuracy with the resonance sensors and amazing stability. So as an option on a 542, you can actually extend your calibration period to 15 months. That's standard on the next model, which is the 552, and the 552 can be extended to 18 months. So it's a real cost of ownership. You think over the life of the instrument, you're taking out all those calibrations, a huge difference in the cost of ownership there. Okay, save and recall ADTS settings. So what's that? Okay, well, I mentioned at the start that you go in and it starts up as helicopter. Okay, fair enough. And you go in then, and I'm working on this particular aircraft, and I've got to go in and select that, and then I want to change the units. I want to work in a different pressure value. So once you've set all that up, you can hit save ADTS settings, and it will save it, and you give it a name. So when you come back to your ADTS, you can put your name in there and say, in my case it would be JED, for example, A380. I just go to JED A380 and it would pull up all the settings I've got there. And once I've saved it, all I need to do is recall it. So this one there called JED1, so I hit that and it says, hang on a minute, look, I'm going to set the whole ADTS touch into what those settings were that when you last set it up, and save that as parameters. So I was in helicopter mode, now I'm back in max aero, so everything has gone back to the settings I'd saved against my name for that test. So it just personalizes it and saves time having to go in. Again, you know, you've got altitude correction if you put that in for a particular aircraft, and you've put you've edited limits, etc. So you don't want to do that every time. So just save it against your name. You can type the text in, alphanumeric keypad. So it's very simple. That's the beauty of having this touchscreen interface. I'm sorry, I've moved it a little bit. May lose focus on the camera. So that's what we wanted to do, make it easy to use. It's a capacitive touchscreen. It's not a mini iPad. It's an industrialized screen, and it's something that we've designed ourselves. And yeah, it's got some huge advances in that regard. So system status will go in, and we can talk about the ADTS pumps, for example. It'll tell us how many hours the pumps have been running, and how many. This is demo unit, and also the sensors as well. We've got software installed. So what's the build software? Now the beauty of this design, and again the commonality across the 542, 552, 553 and 554, it's the same unit, same box. So if I paired this from the 542 with the 554, it would work with the 554 in 4-channel mode. But the fact that it runs on a, if you like, a PC-based background, it means that when we add up features to the unit, or we can add enhancements, we will offer those enhancements free of charge to our customers that can download from our website, and we've already done that since the launch of the product. So we go onto our website, save it onto a thumb drive. There's a USB on the back. I'll give you an orientation of it later. I don't want to lose the focus in terms of the camera. So yeah, so you can check if have you got the latest software build versus what we've got on our website at that time. Okay, history, calibration software, hardware, any messages that you've left on there as well. So communications, it's telling us we've got great communication there between our Bluetooth and our ADTS. Okay. So that's tools, pretty much covered in, without going into the calibration menus, which is not the purpose of this video. The purpose of this video is to show you the features and how easy it is to operate the device. Finally, we've got something here called engine pressure ratio. So this is testing on the engine, obviously, and those of you in the business will know exactly what it is. So there's instruments in the cockpit to indicate what the ratio of inlet to outlet pressure is on jet engines and on the engines on the aircraft. And it's a very important parameter for the pilots as well. Depending on the load of the aircraft, how heavy it is with the maybe passengers and freight, or just freight, they'll be calculating what EPR they need, and they'll also obviously have a minimum takeoff speed as well. So EPR testing, because this is if the EPR device on that engine is using pressure, then we can use this device basically to simulate EPR pressures and ensure that the sensor measuring the engine pressure ratio is working correctly. It's an option, so if you don't want it, you don't need to buy it, but it is an option and additional software in there for it. But it's a great feature for those of you interested in testing or needing to test EPR. Okay, I'll just slide over to the right. There's one other here called a test sequence. This part of the unit is what I mentioned earlier, that we can continue to develop things to make this better and more useful in the future. So we will provide a template for you to build a test sequence, and that test sequence can be saved via a thumb drive, USB port, onto the instrument and recalled. So that could be a test sequence for a leak test, or a full test sequence for the cockpit instrumentation. And instead of having to manually enter every step, what it will enable you to do is simply step through the process. In the future, we hope and we are working on capturing that data as well and being able to report it out. But I'm saying that now, but don't wait for it. Again, that's the beauty of this instrument. We can update that later. But for now, we've got full capability of being able to, for you to be able to build basically in Excel, and we provide a copy of a typical template, and you can build a full test routines, and you put many test routines into the instrument and just call those up and step through them one by one. Okay, so that's test sequence for you, and that pretty much covers everything, I believe, in terms of the instrument and its operation. So as I say, it's very simple: measure, control, pressure, aeronautical, Mach, airspeed, knots, effort meter. Are we there? Let's set a value. Just tap on aim value and we'll go to 30,000 feet. Off we go. Very, very straightforward. So I'm in control mode now. Anytime I want to pause that, I can actually use this feature. I'm just going to pause and it will stop. Close that. It will stop the instrument going any higher. Okay, put that back off. Hit tick again. We can control the aircraft. Okay, so for now that ends this video. There will be some more coming and a few more features to point out.